Well, after a long dry spell of not much of interest in the humanoid robot space, we definitely had some interest yesterday, or at least Brett Adcock thought that there was something of great interest. So we've got the Scott man himself. There is nobody better to get on board. How are you doing anyway?
Oh, I'm doing fine. And yeah, let's say there was quite a dearth of information coming from everyone because you remember for a while there, one person would announce something, and another company would come out, another one, and then
Right.
it seemed like that was going back and forth, and then suddenly just silence, like everyone's been on holiday or they've been working hard on other stuff. But we had some hints of things that were coming on, and I'm probably not as prepared as I should have been because I seem to remember I had clipped a couple of posts from like going way back. If you go back to, I think it was the 6th of June, the 20th of June, is Brett put out a post talking about that they were shipping, a small fleet of robots to a client, and you could see the packing box, and you see the
Yeah,
packing
we
box
did get
was
it.
was
Yeah,
empty.
we showed that on the show. Yeah, we showed.
Yeah, yeah. So it was empty, and the outline in there just didn't quite match the figure one robot. It's a little bit different. And so when the announcement came out last week that sure enough, that they were getting ready to reveal the figure two, Brett also reposted that thing and just talked about 6 weeks ago with like a little detective thing on there, which made it clear that, like, okay, it's about the customer that they kind of sent it to, and you could see from the new profile that they have of the bot that it kind of matches the backing cutout and everything else. So that was like a hint that something was coming, and then certainly he promoted it. I think the way you expect an advocate of your company to promote stuff. Sometimes maybe they're a little bit over the top and go overboard, but yeah. So let's say that then caused people on the other side to kind of come out and say, hey, we disagree. And that's fine, because now what that does is it gives us visibility where we haven't had visibility before.
Right.
Right? Yes.
Yeah. So they told us on I think it was on Monday that they'd be announcing on Tuesday morning, and they gave us a little
Yeah.
teaser
Give us
video, and
give.
then
Yeah. Yep.
and
Yeah. Short video. And I have that. We can go through it kind of slowly if you want. I brought it up
sure.
in
Yeah.
Camtasia because it seems to be the only um, only one that allows you to go like frame by frame easily. All these other playback units are pretty bad about that.
Right,
So
right, right.
I'm just going to go ahead and show that screen that we have right now. We'll go ahead and share that. And so I'll just go ahead and play it first one time through, and then we can slow it up. So you can see it definitely looks different than the original. That you don't have as many cables or anything else coming out, so it's not surprised it's called Figure Two. In the teaser video, we saw a little bit more of what's going down in the foot. We don't see quite as much there. Um, and a lot of people have mentioned that this looks like, oh, it's just a ripoff of the Justice. This is actually a ripoff of the Figure One announcement video right here, because that's basically some of the same angles. The first 10 seconds, yeah, that was like throwing shade at the Gen 2 release. There's no doubt about that. But we're seeing a little bit more. We can see the camera suite that's in the back. We see that it has a funny kind of Cyclops head that's able to move 2 degrees of freedom there, and also a change of shoulder design. This reveals some things that we didn't see in the teaser video, but there's also a lot of other things in the teaser video that are not being shown here that we'll kind of talk a little bit here. But the first thing was like, okay, let's start counting robots, get an
Right.
idea of how many are there. And when you're done, you end up counting 5. So I guess the next time someone says a small fleet of robots, that's what they mean by, that means 5, I guess. I was trying to figure out what's a fleet, and the definition is like, anywhere greater than 1 up to 100 or something like that, like a naval fleet or something like that, or fleet of cars. And so here we see it actually in the production line, and I'll go through this kind of an excruciating detail and what we're seeing on here, but overall showing what I've always referred to as the low-hanging fruit in the automotive plants, that there's plenty of example stations like this. And actually, up to this point, I'm very disappointed we haven't seen this from Tesla yet.
Uh,
We see them packing the batteries in, but I'm expecting them to see this because there's so many stations like this, and
uh,
it is so easy. And aren't they showing that? So because it can be done, but there's still some aspects to it that will be a bit tricky. Okay, so what were your thoughts at the beginning? I mean, everyone says that the first, I don't know, 10, 20 seconds here is very similar, no doubt about it. And it was maybe just, again, it's like, intentional just to kind of provoke and everything else there. But then as you start going around here, like I say, that they're just giving you the view of the body and some of the changes that have been done. We can see that they really changed the hip area in here quite a bit. So your primary actuator, the one that goes right through here, is like the most important one. That's the one that gets you to walk. Okay. Now, the question is whether they have spec'd it to have high enough torque to be able to get the walking speed that you want to get out of it. But I would definitely make that the primary actuator, and all the others would be a little bit later on down. Now, we did get a breakdown in some of the quotes of some of the things that may not be obvious right here. And the first thing is that they've gone to an exoskeleton design. So rather than using bones, and then having to have stuff on top of the bones and then covers on top of that, it's like, no, the covers or the skin are the structure of it. And that's not a bad thing, because what that means is that it's kind of hollowed out. It's a lot easier to run your services and everything through there. Mm-hmm. So they've done that to try to manage the cabling, because we know that's a hard problem to try to get that to work. So they've done a pretty good job of being able to cover that up. And now, in theory, the exoskeleton should reduce the overall mass. Mm-hmm. And I'm not sure what the mass of figure 1 was, but most of them, were probably around 55, 60 kilograms. Some of them are lighter now. We're seeing that. And it's one thing to go to a website and look at the specs of all the bots that are out there, because they all have their specs, and they're almost all of them are aspirational. Right. So they'll talk about a walking speed, and we have not seen that demonstrated from many of them. They all want to say, yes, we can walk 5 miles per hour, but none of them are showing them walking 5 miles per hour. Right. And they may show that they can lift a certain payload, which, it seems like they might be in the area of being able to do that. And also like the overall weight. So it's actually around 70 kilograms. So it may have put on a little bit of weight. And part of the reason to put on weight is that the size of the battery pack increased by 50%. Mm-hmm. They've gone from probably a 1.5 kilowatt hour pack. I wasn't sure how big the one was before, to definitely a 2.25 kilowatt hour, which is almost the same as the Tesla bot. It's right around there. Okay. And so both of those are kind of almost in a league of their own, because everyone else is around the 1 kilowatt hour or less. They have much smaller battery packs and much smaller run times as a result of many of them. But the reduced mass allows you to do a lot of things like, backflips and everything else. So that's one of the things. And I have a feeling they've got 2 layers, because in the teaser video, we could see the batteries that were in there, and we could count the batteries. And I counted 66 batteries, which got me to like, oh, that's like right around a kilowatt hour, right? Uh-huh. And so then they must have like a second stack behind that, a second layer that allows them to get up to, I guess, what's that, 132 or something like that. So, yeah, that's about the same as you see in the Tesla bot. So they changed the design down here. They used to have like these bar linkages that were in there to be able to get the torso movement. Mm-hmm. And they've chosen to go to just, stacking 2 rotary actuators here to give you the movement that you need to have. And that's important for being able to walk correctly and keep the bot horizontal and steady when it goes around. Now, one of the advantages of the exoskeleton also comes down to robustness, because Brett pointed out in his post, like the first bot was not really designed to fall or to survive falls very well. Uh-huh. And having talked to a couple of the other bot manufacturers, and they say like, yeah, their bots, like after they fall 1 or 2 times, they're like really severely damaged. So that's why they're always having them on harnesses, because they're really concerned about that. And we know these things are going to probably fall over a lot. Uh-huh. So you have to design it for robustness. And of course, you do that. I mean, one of the compromises is that it may end up being a bit heavier than you expect. Yeah. So we see that there's a change in the hand. Well, I think it's a 4th generation of their hand. I don't think kinematically it's changed very much, because I think they always had 3 knuckles. And, so it's kind of the same movement that's going on there. What they have done is they've cleaned up the wrist a little bit, so it's not as bulky as it used to be. And, as a result, you see that they're running all their services right through the conduit right in there. And so, yeah, so it's still 16 degrees of freedom. And it's a different wrist design. It's a serial wrist design, which is different than the Tesla bot, which is using a parallel kinematic for that. But they've changed the shoulder a little bit. Still, it's similar to everyone else's shoulders. But all right, what's going on here? What do you see, Randy?
Well, everybody wants to see about the walk, and
Right,
how fast
right.
is it walking? How clever? How, does it look human-like? Does
Yep.
it look steady, sturdy? Does it look like it's confident? And to me, my first thought when I saw it looks like all the rest.
Yeah, yeah. So I'd say is that one of the first things is it seems to be plodding, so it's not getting any heel to toe here. So it still seems a bit mechanical and stiff. It's a bit more upright than figure one, but figure one was like very slow. This one is just slow. Okay. So they may have doubled the speed, because I think I tried to do a calculation on figure one, and it was like really shuffling very slowly. And it was like maybe, about half a mile an hour, a little bit faster. It was definitely under a mile per hour. This one is probably, counting steps and looking at the time and assuming, anywhere from 10 inches to 12 inches, it's hard to estimate here. This is over a mile per hour. And it's about the same as what the Tesla bot's doing. So the Tesla bot is also not fast. I've been, I think, kind of vocal on Twitter about this.
Right.
I think they're both too slow for me.
So
they need
the last version.
Yes. So even the Gen 2 Tesla bot is very slow. It needs to double its speed. 1.3 miles per hour just will not cut it. You've got to be at least 2.6. That is the standard of what you use for assuming the walking speed for humans in the factory. And you can't get another 30% boost. You've got to double it. Okay. And so now, do they have a pathway here to be able to double themselves? Now, if you put this side by side, looking at the Tesla bot seems a lot smoother and a bit more graceful going through. Right. You're seeing the heel to toe and over there. You're seeing a little bit more in that. And so that might be one of the things that they have to start working on themselves over time, depending upon how they do it. Now, one of the things we can see that their bot is doing that others have not done that well is it is walking backwards. Okay. And that's very important to the actions that are going over here. It needs to be able to step away, because that's the more effective. It's able to turn a little bit faster because they now have the abduction motor, as we can see, it makes the turns a little bit quicker. Still not really snappy, but a little bit better.
Okay.
If we just go back for a second, the background in here is that this is definitely, and as we see, they increase the amount of battery that they have in there. This is down at the BMW in Spartanburg, but it's in an area where you do a lot of the prototyping, where you start testing out, new automation, new schemes to bring it in to do your runoffs and everything to make sure it's all right before you do the installation. So it's down there, and they are using the fixturing that they were going to have on the floor, but everything else is missing. So it's not a real turntable. It doesn't really have the full safety fencing that's in there. Obviously, the robot's not back there. It doesn't look like they have the clamps, or the clamps may not be acting, because this is a training area. They're trying to get it ready. And then, they finally get to the point that, hey, all right, we're ready to test it out actually in the production hall. So we can see the differences with what's going on here in the production hall. And, it's got to pick up 3 different parts. One of the parts is big enough that you need 2 hands to be able to do it, just to be able, not because it's heavy, just because, of its size. And the other thing is that the accuracy that's required for the placement here is not very high. These stations are designed that it's very easy just to drop something in. All I have to do is get the orientation kind of right, and we're going to see that these tooling pins do the alignment. The final line. So all I have to do is get these 2 holes roughly over those pins, and it takes care of the rest.
Right.
Just drop it down. That's it.
Yeah.
And then you get other 2 pieces that you've got to pick up, and those are easy enough to pick up with one hand. And of course, sometimes when you drop it, it doesn't always drop down right. And it may be that your decision on where you pick that part up in the first place, maybe it wasn't a good idea to try to drop it by coming around that side. Maybe it's going to be smarter to pick it over there or something like that. I mean, these are the things that a skilled operator learns over time.
Sure.
Of what's the way that allows them to pick up a part and then drop it in and get it right each time. But, you know, it's got the corrections in there, and then you've got to go ahead and do it on the other side. Now, what's not being done in the prototyping lab is you see it needs to step back away. And once the light curtain is clear, they drop actually a physical barrier down, and then you'll see the clamps close inside there really quickly right there. That comes down, and that gets the final location of the part where it's supposed to be. And then that turntable is going to spin, going to do a 180, and then the robot's going to be ready for that. So while you're loading this, the robot behind there is working on it. That's the whole idea, is that you want this robot to not have to wait for that. So during the, what is probably 45 to 60 second cycle of that spot welding bot, this turntable is available. And then that's how much time you have to load it, and then get out of the way, and then it'll flip around, and then it will continue to do it, and you do it again and again. So you have the jigs and fixturing on both sides, and they just keep on flipping around and again and again, and you just want to make sure that you're clear and everything else. Now, take a look at this dunnage here. All right, so this is typically where all the parts come in.
Right.
They will be in there, and you can see these things get beat up over time. That's, you see all the dents and dings and everything else. That's what it's like being in a factory. And so this is the type of environment that these bots have to be designed to survive in. So yeah, they're going to trip and fall down. And, you know, there's a good chance that, you know, they'll bump into something, or something will bump into them. That's going to be, you know, kind of sharp and everything else. And they have to be durable for that. That's another reason you want to get rid of the, all the cabling. You want to hide the cabling.
Yeah.
Because I'm going to ask you, Randy, is it wise to walk through a factory floor wearing a tie?
I have done it a million times,
but it's
usually tucked inside a three-piece.
Tucked inside, or you make sure it's one of those clip-on ties. Yeah, it is like one of the dumbest things to do is to ever walk into a machine shop or anywhere else where there's equipment moving around wearing a tie, because there's a good chance you could get strangled. All the thing has to do is get caught in something and pull down it. There's a reason why your long hair and everything has to be up, tucked underneath a hat and something like that, because it's just so easy to get caught on a spindle or something that's spinning really quickly, and then you have no time to react. Right. So, you know, the same problem here is you don't have anything hanging out or loose that can get snagged or caught or anything else that could cause you to fall over or anything else. So you've got to make sure that the bot is not going to get damaged, not going to get hurt. And that's why you're concerned about. The other thing, of course, is that you don't want the bot to have any sharp edges on it itself if it comes in contact with other people. So that's why it looks very cylindrical, because that's like kind of the shape that you want to have to make sure it's not a blunt body that's going to injure or hurt someone.
So,
okay. Yeah.
So back where he was actually loading, in both parts, in each case, it was dropped into place. Yep. And I thought that was for as far along as we are in this process, for as far along as they think they are in this process, that still seemed awfully clumsy. It needs to get better. Now, it could be that they just wanted to show it the fact that it's able to self-correct when it got it wrong. We don't know whether others it's just kind of dropping in really nicely. I think we've seen some other examples with Figure 1 where it was dropping in more cleanly the first time. Okay. So you have, you know, the cycle time on this is not like super demanding. Right. So you have a certain amount of time to do it. You can make these little mistakes you can correct from. And so they're probably just able to get this within the cycle time. But the thing I want to point out here is we are not really seeing a pick and place operation. Yeah. We're seeing a place operation. Right. Because the pick is artificial. And the reason why it's artificial is look at where everything's getting picked up from right here. So you see this frame right here, it's got a single piece on it, and it's got another two pieces right here that are presented very nicely and very easy. Right. Where's the second and third and fourth and fifth? Where are the other ones coming from? Okay. I'll tell you where they're coming from. Some human is pulling them out of a bin and bringing them over and dropping them on here in a place and then be able to pick it up. So they're really working on that aspect of it, and not, you know, this part here, you know, there's a lot to be gained and learned from it. But in the end, this is going to be tricky. And this could also be why we're not seeing Tesla doing the same thing, is that this side of that operation is real low hanging fruit.
But this front side is a bit different. And what we want to see is like this orange crate that you see here. This is the typical dunnage that all the parts arrive in.
Right.
And they're just kind of in there in a jumble. I mean, they're loosely organized, but they're not perfectly organized. There may be some of that are a bit different. I think there was an image really showing them all messed up. So it's going to be the robot is going to have to go down and in there. And normally, of course, operators are wearing gloves that are very thick because that sheet metal is very sharp and you can get cut on it. So you've got to try to find the piece and you got to get leverage on it to be able to pull the thing out and get it up and over. Right. That's not an easy job. Now, you know what sometimes it's like when you got a stack of plates and you want to pick a plate up there, you've got to get your finger in underneath that and sometimes separate them, and then you can get your leverage. And if you get a bunch of these sheet metal parts that are really, nested together very closely, it may be like trying to separate a piece of paper or something like that. Yeah. So that's where I see is going to be a lot of the tough parts, the efforts, because these are going to be disorganized. You're going to have to go down there. You're going to have to identify the part that you want to have, and you have to go in and get that part and then pull it out. And that's what's going to be interesting to see whether they see that as being an issue or not. And again, I think if we kind of back up here, this one here, you're kind of looking at the dunnage, and it's telling you that it's like, oh yeah, you see all those parts that are kind of in there. Yeah. Because someone is coming over and pulling one out and then feeding in here for the next one. Or in this case, they're probably just recycling it because these parts don't go anywhere. Obviously, in the real floor, they go somewhere else. And on the real floor, this has been changed, is that I guarantee you that frame that we're seeing out there on the production hall isn't there all the time. It's only there for this demonstration. And more than likely, you've got another one of these sections sitting right in there. And you'd probably have another one right over here because there's 3 parts. So each one of them has to be its own dunnage that you're pulling from. So that's out of the way, and that goes in there.
So as clumsy as all this is, as slow as all of it is, it's pretty darn sophisticated, given that they've only been at it for 18 months. But it's kind of like FSD on a car a year ago or 2 years ago. It's like, okay, it makes some mistakes and it does these things slowly or doesn't do it the way we'd like it to do it. But it was such a proof of concept that you're just like, you sit here and watch this and you're like, well, yeah, I could employ that in a factory right now. I can think of jobs that it could do right now in my own factory. It might be slow, but okay, it's free. I mean, well, okay,
it seems to be okay. And again, I mean, we can see that, you get these sharp metal parts, you got the hand that's coming in here. The hand does seem to be pretty robust. They've added a lot of padding and everything else on there, but it's going to be interesting to see what it's like after, doing a real full shift for a week or something like that. It's like, whoa, is it going to be able to make it the end of the month or something like that? Or these detachable pads? Or would you be considering actually having some sort of cover for these things? So the robots would have some form of PPE of their own to be able to protect them from what could be. And these things are also going to be a little bit oily. Yeah, I mean, you've also got that to kind of deal with. Not just that it's sharp, but you also going to have something which is fluids on there that you don't want to really get all over your bot.
Sure.
So those are going to be some of the challenges, and I'm wondering if there's also some of the similar challenges, because to me this has been the low hanging fruit all along. That was very clear in the records, like, this is it. And Elon even said they talked about loading that. And that's why I'm disappointed just to see, you're only doing with the batteries right now. Come on. It's like, over here, you get that SNX line, which is idle most of the time.
Right.
It's running one shift,
right,
and stuff like that. And it's got way more of these stations than the others, because the others are using gigacasting, right?
Yeah.
But the SNX, they still have that whole underbody assembly and stuff like that. They've got all those parts that have to be spot welded, and there's just lots and lots of things like that. And once you get that, so that's why Elon can make kind of that statement of like, we'll have about 1,000 next year in our factory.
Right.
And it's a good chance that, a lot of them might just be the SNX line, because that is such low hanging fruit. Right. And it's the perfect prototyping area, because So what if the production, goes down a little bit for that week? It's like they have no, it's not like they have the demand for it. They have to worry about it. So, and they might actually get the demand to go up if they can say, bodied by Optimus,
Yeah.
you know, it's the thing about, there would be a lot of people that are buying the Foundation series of Cybertruck. I think a lot would buy the SNX if they had something like, it's got the Optimus brand on it, because that was like the first cars where you could really say it was involved in there. But I think, the other news we can talk about was just the podcast with Lex Fridman. Did you get a chance to listen to any or all of it?
I have listened to about I think I'm almost up to 2/3 of it.
Mm-hmm.
I've just finished the section where they're talking about the robotics being used to place these in the brain.
Mm-hmm.
The actual, the threads going into the brain, and
Yeah.
the
Yeah. The
surgeon
robot for being able to do that. Yeah.
overseeing the process
Mm-hmm.
and whatnot.
Mm-hmm.
So that's about where I am now. But no, bring us up to date. What kinds of news?
Okay, I haven't had a chance to listen to it myself, because I've got so many other things. I mean, it's like 8 hours, which is crazy. Even at 2x, I mean that's quite a bit. But I have had a chance to listen to some of the clips that were already posted out there that people brought my attention to, discussing bits about Optimus, and so we keep on getting a little bit more hints and visibility into the 22-degree freedom quote hand,
Right.
Because when Elon first kind of talked about what it was going to do with those little hints about 2 months ago, we had to definitely read the tea leaves on that, and then talked a little bit more at the shareholder meeting, and then at the X takeover he kind of got into it a little bit more. And I'm not sure when he did this podcast with Lex whether it was before or after, but it's clearly really been on his mind and wanting to describe the whole process behind it. So the current hand is 11 degrees of freedom, and the next hand is going to be 22. And you can sit there and try to count what those are going to be. And we have a pretty good idea. They're adding an extra knuckle everywhere. The fingers will be able to do this rather than just that. Gets us up to 19. Where's the other three? And I've always said the other three were probably the wrist axes, because he already mentioned that it's going to go in the forearm. And so the whole rationale is getting the inspiration from nature. So they started out taking the typical kind of Tesla first principles approach when they did the hand design. And you can read about that in Walter Isaacson's book.
Right.
And it's rather interesting as they went through and figuring out that. And the arguments are like 3 fingers or 5 fingers. What should we do? And then what kind of sensors to put in there, and the decision not to put the sensors in there. And we'll put them in there if we figure out we need to, because that's Elon's mantra, is like, take them all out. And if you're not putting some back in every now and then you haven't taken enough out. So how do you know whether you need a part or not? It's like, you got to put it through its tests. So you want to be kind of scientific about it. So we know in Gen 2 they've gone ahead and put tip sensors in there, because they've decided that there is some valuable information in there that they're going to augment with everything else. And it could also be depending upon the design use. I think there's a lot of uses that you don't need fingertip sensors. Plenty of them.
Mm-hmm. Yeah.
But then I can also come up with a bunch of others where it really comes in handy to kind of have that. So that means they're looking at what are our use cases, and probably came to that conclusion. We have to go ahead and go with that. Now, the original hand, they took away a knuckle because they thought, well, do you really need all the knuckles that are in there? You can make the argument whether you do or don't. And in the main argument is like, the best part is no part. So if we just get rid of one of the phalanges there, then that doesn't matter. We reduce the part count. But now it appears they've realized, no, we really need to put it in, because the hand is then able to get a better kind of grip to the different kinds of shapes. So, okay, so that's going in there. But the other thing that they did is that all 4 fingers have the same length in the Tesla hands. So again, it's just like, yeah, I mean, it's like you haven't got rid of parts, but you've got rid of SKUs. Okay. And SKUs sometimes can be worse than parts, right? Because it's just like one more thing that you've got to track. So if you keep them all the same, everything's interchangeable. It's much easier, just like go down that route. So the question is that when they're going to this, are they going to start changing the lengths of the fingers? And it's not quite clear, but when you listen to Lex's podcast, it seems to me they might, because Elon talked a lot about the importance of the pinky.
Yes, he did. Well, first of
In
all,
there,
he said that the length matters, and
the
that
length matters.
and that there's a definite benefit to dexterity.
5 fingers and the pinky and everything else. So they've looked at it.
You'll remember our long discussion about my oboe.
Yeah.
I found out just how important that left finger was.
That is, yeah.
It took me out of the game because I didn't have that kind of dexterity anymore. Didn't have pinky.
Didn't have the strength there. Yeah. So depending on what you do, and I don't know if that it's we want it to be an oboist or a flautist, which is the proper term for someone who plays the flute.
They changed it back. You didn't hear. It's now
they changed it
again. They keep changing it.
Yeah, I know they keep it here, but it's supposed to be flautist, not flutist. Okay.
It's pretty funny how I'm
flouting my knowledge of.
It's pretty funny how we've based a lot of Optimus's abilities on instruments. So first it's the piano, then we talked about the flute versus the oboe, and then the violin as being the ultimate test. If it could play a violin.
Oh yeah.
Then it's
the pinky is like really big in the violin. There's no doubt about that. Both are like holding the bow correctly as well as it's
oh my goodness.
But I'm assuming that's not the use case. There may be these other use cases, because at this point it doesn't have quite enough dexterity, because it can only do the fingers like that. It can't do it like this. We know it doesn't have separate control. And so the control is moving out of the palm, which will make the palm thinner and bring it back here. And then they're looking at designs on the wrist. So right now the wrist is pretty thin, but you still do have like the control rods that are there that they might be thinking moving out. And so, but Elon went in talking about, how you have the tendons or the puppet strings that are in there and going through the carpal tunnel and the importance of that, which is telling me they really want that wrist to be much smaller. And they may have a different schema now on that, because he says like 50% of the engineering is going in the hand. And actually
50%.
Yeah. And that, the other thing is he talked about it as being a 22-degree freedom arm, meaning the lower arm. And at first I thought maybe he misspoke, and then he doubled down, saying it really is it's a lower arm. And I completely agree that
I know you were the first one. We broke
it is like from the standpoint of trying to build a robotic arm with an end effector and stuff like that, and doing the analysis on there. It's just always been this convenient thing to draw a line right there and say the hand is after this and the arm is there and the wrist is part of the arm, and you separate those things out, because it's just a lot easier to do the calculations and solve the whole thing. But the thing is, you can't decouple them completely. There is always a little bit of feedback from one to the other, and if you make it like a single unit, there's huge advantages to being able to get the kind of control that you want to have. So a lot's going on there. And then we assume there might be more going up the arm, potentially, but a lot. And then talking about the manufacturability of it, it also, Elon sounded like it's going to be a challenge. Yeah, so part of it is how they're going to pack everything in there.
Let's go back for just 1 second. Just make it really clear, because sometimes, we're so deep in it, other people don't understand. So the arm from the elbow, Elon was very clear. Right. The elbow to the tips of the fingers, that's a part. That's a lower. Yep. That's the
22-degree freedom lower arm. He's thinking the hand is being part of the lower arm, and that is in the end really the correct way to think about it. Part of it is because all the actuations and muscles, the majority of them are up here in the forearm.
Right.
And then after that is where you have the wrist and everything else.
And he was not clear, but I think we could maybe surmise that at least one or more fingers could be a different length.
At least the pinky.
They might be placed differently in terms of where they start,
right?
Which will give the appearance of being different lengths, even though they are.
Yes. So you get like a little bit of an arc right there along the attachment points that causes an artificial kind of offset that you think the fingers are different length, but it's really not, because they're offset. So we don't know. It might be that 3 of the fingers are identical and the pinky is special. But in the end, Elon thought it's building that may be a bit of an effort because of everything that's going to have to go in there. And the question is, how do they find the space that's in there?
Yeah.
Because they already took up a lot of that space with the actuation that they want to put on the wrist.
Right.
And then, they've got these two big actuators in there to give you just 2 degrees of freedom of motion on the wrist. And then that whole unit has to spin very close to where the elbow is, and, pulling that trick off and everything else. So, it's going to be an interesting challenge. I suspect they may have come up with maybe a better design on some of their linear actuators, because I suspect that's what they will be using.
Yeah.
I mean, you basically have to take these strings and pull them and then release them and pull them. And one way of doing it is that you could come up with something that's almost like a solenoid or linear actuator that just is able to pull on that and release it, and pull on it and release it. And the other is that you just have a winding mechanism, which is what they have right now built into the hands, is that basically you get a little spool and you just wind it in and then let it go out. The other thing is remembering is that if you're using tendons work well in tension, but they really suck at compression without having some kind of sheathing and everything else. So they're going to have something like that to allow them to kind of run through it. But at some point, the only way the hand opens up is that you relax the tendon, and you've got springs that are down here that allow it to kind of pop open.
Yeah.
So it's interesting design. Now, you could get away with it in other ways. You could potentially run a second tendon that's designed to pull back the other way. So you could have like 2 puppet strings in there, which I wonder if they're considering that. And then that would allow you to open it up really quickly. I don't think you necessarily need to have like a whole lot of force in this direction. You want to have most of the force this way, but potentially, depending on how you pull on that, you could persuade it to open faster if you want to, but that just adds more complexity in the back. I would think they probably would not do that.
Yeah. So then you were saying about just how hard this is. So Lex hinted or intimated that maybe this wasn't, anywhere close to as hard as a car or some of the other things. And Elon clapped back and said, no, this is really hard.
Yeah. So especially when it comes out of the hand. Now, we don't know what else is going on, because let's say that Brett was really good at kicking over the bee's nest yesterday, and provoking a lot of responses. Some from 𝐓𝐞𝐬𝐿, who pretty much hinted last week, as soon as the figure 2 announcement came out there, it's like, oh, we get some things to show. And I'm like, okay, I'm excited about that. Now show us your hand.
Yeah.
Okay. And there wasn't much to show except kind of complaining about, wait, this looks an awful lot like our video. And it's like, okay, but show me the money is like where it is. And I think the one thing is like, all right, I showed a nice little montage of the Tesla bot walking and also the figure 2 bot walking. And all you've shown to me is that if figure copied anything, they copied that their bot walks as slowly as yours.
Yeah, right.
Okay. Seriously. Okay. It's too slow. Both of them are just too slow. And I don't want to hear this that, oh, we're working on that. It's just a software thing. It's like, it's been a while. Okay. It's been a while. You promised us 5 miles per hour and you're barely over 1 mile per hour. And you don't need 5. Don't give me 5. As in fact, if you look at the figure page, they never promised 5.
Oh,
They've only ever promised 3, which is good enough, because you only need like 2.6.
Right.
All right. Now, you do have these bots over in China that are going as fast as 7 miles per hour. And that might be a bit of overkill. And part of the reason it might be overkill is that they can walk really fast, but then they need to recharge 30 minutes later.
Right, exactly.
They don't have a whole lot of runtime on the batteries. Okay. So it's like, all right, at first I want to see, it moves really gracefully. There's no doubt about it.
Right.
And you're getting that real nice, toe off and everything else. But what is holding back the speed at this point? I don't believe it's just software and you haven't had a chance to work on it. There's been more than enough time. So there may be some other retooling that they have to do that will be solved in Gen 3, and that they might just say, we just can't get it. There's just something fundamental about the design approach that they took. And the thing is, a lot of times people will say torque and acceleration go hand in hand, or force and acceleration go hand in hand. They don't necessarily. Mm-hmm. So just because you have a motor that can lift up a grand piano, it's got a lot of force in there, doesn't mean it can deliver the acceleration and velocity. Right. And in the end, it's velocity that you need to be able to walk quickly. And it may be that they geared that thing down so that it's like it can apply a lot of force. You're pushing on that thing and like, oh, that thing's got a lot of resistance, a lot of force. But as far as like its movement speed, it may be too limited, and it may be that is what's restricting it. Because I'm just like, what's the problem here? The only other problem could be is like, well, to get the speed, we need twice the power output.
Yeah.
And they're like, they don't want to go beyond the 500 watt limit there. Right. So it could be, they're like, oh, okay, it's going to require too much power to be able to do that. And maybe that's a problem. So I have a feeling that there's something other than just that. I hope I'm proven wrong. Okay. So if you're listening, Milan, to this, then go ahead and show. I realize that there's a lot of things they don't want us to see because they're it's going to come on the right. But we've been talking about that there's some updates that are coming. Show me something other than taking the cylinders off the line and putting them down there, because that's not really a challenge. That's easy pickings, because it just comes off of there and you have almost the same location each time. It's a very simple part and you're dropping it on down there. Picking up sheet metal out of bins is a challenging problem. And it's so challenging, we haven't bothered to automate it until then now. Okay. So show me that you can go ahead and do that. And then I'll get off your back. Okay. So
what did you think about the 6 cameras? Is that the right number? Do you think that's what
I think the Tesla bot has it's a unique, different placement. John Gibbs went in a little bit, because in the front, it was a little bit surprising because you're expecting like, oh, the camera suite right up here on the forehead. There should be that. Instead, it's like the Cyclops. And it's like, well, where's the stereo coming from? Yeah. And they have 2 smaller cameras right down there in the chest. Huh. I probably should have pointed out that, if we want, I'll just quickly go back and share that so we can take a look. And then I need to go find the show. It's like, oh, okay, where's your Zoom controls go? It's like, okay, I'm going to be poking around here. I hope you've got a good editor out there.
Well, Randy, because if it really takes us a long time to figure it out, Scott, then we'll edit it. Otherwise, we'll just make the people wait. I'm sorry.
Okay, man, it's going to be work. Oh, there's the controls over here. Let me see. It's like I'm trying to find where. Okay, it goes on down here.
Yeah, Zoom just changed everything. So about 3 weeks ago, so it's become.
Okay. So if we go right back here to the cameras that they have. Okay. So I think we see it right about. Okay. So we can see here, there's one camera right in the middle, and maybe I can show that off a little bit better. And then right down here, you'll see there's a small camera there and a small camera there. And so that that creates kind of a nice triangular area where this is fixed and stable, and you have that one that's moving around. Yeah. So from this, they may be able to get a pretty good idea of where they are as far as location, and because the head's able to move around, they're able to see as much as possible. So the Tesla bot, I think, at least in the patents, we don't know what's actually in there. We think they have 2 on the side. Very, very much like on the car. So it looks like 3 in front and 1 on the side and 1 on the side. So this is different than what just about everyone else is using. They're all having 3 up there. I know when you look at the Sanctuary bot, Phoenix, it's the same way. You have 3 there. And then what's kind of surprising is in the rear, because we just think all you need is like 1 camera in the rear. I mean, it's like our Teslas. We just have 1 in the back from the back in the part. It's a wide field, and that's it, because you basically don't drive backwards that much. But when we look here somewhere and right there, these are the cameras in the back. There's 3 of them.
Wow.
So there's a certain importance to being able to have that. And now this is looking down and not up. So I've mentioned that basically it's exposed itself to attack from raptors. So
Yeah.
like, a big hawk or something like that can come down because it won't be looking up, it won't be looking up. And so long as its head is forward. So that's where its visibility is. These are like the e-stop buttons and the power on in some sort of status. So that's what they have and that's what allows them to walk backwards, which we could see is pretty important to the application.
So Scott, it's pretty interesting on the front in terms of having the middle of the forehead and then on each shoulder, with everybody that's been talking about how important it is to duplicate the human so that it makes it easier to do the training. Because if you start moving things around, if it's not like a human, it would seem like the cameras would be almost the most important part of that theory. Because if your cameras are in completely different places, then you've got to translate every single movement to.
It could be a little bit different. And so, I mean, you have the main camera that's there. See, I'm looking in here and I'm assuming that's just a weird reflection. That's like, they don't have a chin cam, do they? I don't think so, because if this is the case, so that would give you 7 cameras with the ones that are in the back. Yeah. I don't think so, but that's like the first time that's kind of jumped out at me. I think seems to track it quite a ways there in the chins.
But putting it in the shoulders, it would just seem like it would throw it off. If you want the human to be able to do the action, then have it translated directly into the humanoid, it would seem like that would create a requirement for translating every single time. I don't know why that makes sense.
Yeah, I'm not sure why you wouldn't have 2 up in the head just to give you the stereo. I mean, that's but they're getting the stereo from down here on a more stable part of the body. There's a lot of splicing that has to go on. If you think about it, with the cameras on the Tesla, is that they're all kind of in the same location. They don't move around.
Yeah.
They're not on your mirrors for a reason, because the mirrors go in and out, and they're in a place that's very stable. So once the cameras are calibrated, it knows where everything is, because you just kind of splice it over. Right. But if you're taking like data coming from here and you got an image and you got another one that's kind of sweeping around, it's a little bit you got to try to do to splice together to get your entire view out of that. So yeah, I'm not quite sure, but obviously they have people that have worked on the problem and decided that was a solution.
Yeah, be interesting to have Brett maybe respond to that. We'll see maybe if he
does. I'm hoping so. I'm hoping to have a chance to talk with him and maybe even some others from Figure. We'll see.
Yeah. All right. Well, was there anything else from either the Figure One or from the conversation with Elon with Lex Fridman?
Let me see. So I mean, that was the main thing is Elon really going into that. And I wonder if he's foreshadowing other things, that when you start, and I'm going to see if I can figure out how to get Zoom to stop sharing.
Stop sharing.
Okay. Right. Oh, okay.
It's okay. There you go. You did it. Congratulations. Oops, now you're muted though.
There we go. All right. So yeah, I was just saying that I was looking where the stop share button wasn't where it was the last time. It wasn't popping up when you're supposed to. Anyway, he's sort of showing the thought processes going in of, really looking at how nature solved a lot of problems. And this is another thing I brought up, with you, I think in quite detail last week, is that I hope it doesn't stop at the elbow. Yeah. And they continue up and they begin to examine the shoulder and begin to realize that, the shoulder is a ball and socket joint. Should we do the same thing there? Yeah. And should we do the same thing down the hip as well? And it's, if they're really going after the hand and the complexity of the hand, then they've got to be up to thinking of the same thing. Up there.
So, but if you take it all into consideration, as we've talked about so many times before, and Elon just said, 50% of the engineering in the hand, I got to think the other big thing is the vision. Yes, we want it to walk. We want it to walk fast. We want it to be able to back up. We want, it's kind of like the last thing that they're putting on the Tesla vehicles, or the FSD, is the summon and reverse and whatnot. Yeah, you need them. I drove a car for a while without reverse when I was broke, and it's not fun to drive a car without reverse, but you can do it. You can actually manage without reverse.
Yeah. There's a lot, and they can get by. With the shoulder that they have, I just think there's a lot of advantages to thinking about how to solve that problem. And as I pointed out, is that one of the easiest kind of joints to make is a ball and socket joint. What's really hard is to figure out how to actuate it. So making like a simple pin joint like what we have for a door or something like that, it's not a big challenge to figure out, well, how do I actuate this thing? I mean, you can literally turn that joint into a motor itself. I mean, you can do that, or you can use an external mechanism like what we see on a screen door or something like that, where you've got a piston and cylinder kind of there. And you just imagine that as an actuator that opens and closes. And that's what happens in a lot of schools and community centers where you have a handicap access. That's the kind of thing that opens up the door. So that's a pretty easy problem to solve. It's not so easy to figure out how to do it with a ball and socket. But if they're coming up with like something new in that forearm, it may be that they look at that solution and say, well, how could we apply it into some other areas? And then, maybe, but that might just be wishful thinking on my part.
We almost left out what Brett considered to be the most important part of their new product, and which I've been talking about nonstop. So you're talking about the speed. I'm talking about the last component, which is the conversational capability.
Yeah. Okay. So this is the other thing is like, he made some bold statements. It's like, the most advanced one. And again, I said, I will cut him slack because that's what I expect from my CEO of any company is that they have to feel that they have the best company, the best team, the best products and stuff like that. And if they don't, what the hell are you doing there? Okay. You've got to believe it. They've got more visibility on what they're doing internally than someone else is. Now, sometimes they may be, they also have to admit to themselves where they are to realize that are we really in second place or third place or something like that. But you might say based on what we've seen and how you want to define the metric. And again, if we look at it and say both Tesla bot and Figure 2 are slow, H1 from Unitree is really fast. Therefore, they're the best robot in the world right now. And it's like, yeah, but it doesn't have hands. It doesn't do tasks. It doesn't have any AI. It's like all this other stuff. You can't just score it on the fact that it's a really fast thing. So we've got to look at where's the whole thing. Sanctuary probably got the best hand out there right now, but they're not mobile. They can't walk and everything else. So again, it's like, well, let's get an apples to apples kind of comparison here. It's going to be a humanoid bot. It's like, okay, let's throw Atlas in there, the new electric one, because that one walks pretty fast. I think it walks at least 3 miles per hour. So it's definitely like, it's got the speed that you need to have. It's got a certain amount of dexterity. But that hand, are you kidding? Those weird three, that's not a hand. Okay. Give me a real hand. And we haven't seen him do anything since then. Okay. So we've only actually seen tasks being performed by Tesla and by Figure and something like that. So you kind of can score them at that. Yeah, they're a little bit slow in walking, but at least they walk. Tesla's a little bit more graceful, stuff like that. Right now, their hands are about the same. Yes, we know about the one that's coming, but we haven't seen it yet. Talk is cheap. You got to show me this stuff. So based on what you see, and the other thing is that, Figure has demonstrated the LLM.
Right.
Elon has said that Grok is coming. It's going to be there. It's not there yet. Okay. So again, I look at this like a marathon. It's a long race, right? And at any point in the marathon, any joker, including me, would be leading the pack. It's like, when I was like in my good days or something like that, maybe I could have taken out the first 3K and been in the lead. But then after that, I would have faded really quick. And then because they're all holding everything in reserve, we don't know what they have. So if you want to look at it right now and say, okay, freeze this point in time and what everyone has shown, you can make the argument that maybe they are the leader, or at least one of them that's there. And I know there's going to be a lot of pushback from other people. Like, how can you say that they're doing this and that? So again, it's very subjective. It's a very subjective kind of thing. Yeah. And again, being very subjective on which bots I'm including, which ones not. In the end, it's like, there's maybe only 3 bots you can put in there, and you have to throw Apptronic in there because the only other one that's like a fully formed humanoid, as far as I'm concerned. Others have come close. Agility is already proving that they're working in the factory. Right. They've got an RI, but they don't have the full hand yet. Okay. Right. They're close. they're getting there. So we can look at all these things, and every one of them is going to feel that, they're very good, or at least good in a particular niche. I mean, a lot of people admit, it's like, all right, we don't have, we're not the largest car company in the world or something like that, but we have like a car that we think is like the most luxurious, it's the best or something like that. So like in our particular class, yes, we're going to claim that we're the best. And that's the role of every CEO. No CEO wakes up in the morning saying, I want to be second best.
Right.
At anything. Okay.
So then you have this business of ability to do the conversation back and forth.
Yep.
He's claiming theirs is really good. He's shown us some evidence of that a few months ago.
Mm-hmm.
His father to show us an update on that. I was kind of surprised at that, since he was making such a big deal about it. I would have thought he would have shown the conversation again if there was any improvement. Elon, definitely. Come on, Elon. We need to see the conversation.
Yeah. I mean, again, talk is cheap. Talk is cheap. You can say it's going to, well, in this case, no, we haven't seen it talk yet. Yeah, okay. But, and we know that eventually Grok is going to be in there, and that may be a while. Yeah. So again, if you're gonna do that and everything like that, our expectations when you look at the trajectory and everything else, it just looks like the Tesla bot is just gonna take off. But there will be other companies that will be nipping at the heels for a while, and who knows? They may also discover, come up with some things that allows them to also move very quickly back in the lead. But we'll see.
And the other thing is the training component. So how does your product, how is your humanoid trained? Is it able to be trained in all the different ways that we've talked about? Is a normal training course a day? Is a normal training course a week? Does it?
If you've got a good foundation model, it should. I mean, yeah, that's what we're talking about. It's like, if the robot really comes with a good foundation model, is able to do lots of things, the training should be very simple. You just demonstrate it to, like, this is what I want you to do, and then it goes, okay.
But that's still something I think each company needs to demonstrate.
Exactly. What does they need to? Yeah, exactly. Right. That it won't just be telerobotic, but it could be either descriptive or that you just show it.
Yeah. All right, Scott. Well, you've brought us up to date yet again, and I think this was a super interesting week. And I'm going to be. There's got to be a point at which. I mean, I know Elon's right now. It looks like Tesla's trying to keep things under wraps for a while, and that might be for good reasons, or it might just be because they're concentrating on something else. I don't know.
They've
got some product they're trying to spring on it on 1010 that could be important. I don't know.
Yeah. That is, but we're willing to see an update. But we'll see if we get something this week from Tesla or not.
All right, Scott, thanks as always. It's been great. And to all of you out there, it has been amazing talking to you.
Yeah, same.